This is a revision video for heat transfer. Here is the learning map that I did for heat transfer. There is a quick about 10-minute video on the Emulsion Science YouTube channel already if you just want a quick recap. Whenever you see the pause symbol here, you can pause it and attempt it if you wish. I'll then go through the answers. The first one I'm going to go through is infrared radiation. In exam questions, the key words you should look for are these. So if they're talking about a colour, so if it's black, white, silver, if they're saying light or dark, it's hinting towards it being an infrared radiation question. If they're talking about a surface being shiny, matte or dull, if they're talking about the size of an object, be it the surface area, if in the pictures there's an appliance and it's designed to either give out heat or take in heat, then it could also be hinting towards infrared radiation. So there are things you should be looking out for to decide, is this question about infrared radiation? Infrared radiation actually occurs in every single object. Every object can emit and absorb infrared radiation, and it does. It's actually an electromagnetic wave. All objects, like we said, emit or absorb infrared radiation. It doesn't require a medium to travel through. That's a really special thing about it. It can travel through a vacuum. So all objects will eventually lose their heat through infrared radiation. Things like vacuum flasks will lose their heat. It won't stay the same temperature forever. Infrared radiation is a transverse wave. All EM spectrum waves are. And the special thing about this is that the vibrations or oscillations, we can call them as well, are perpendicular to the direction of energy transfer. Okay, that's a key thing you need to know about them. All objects emit or absorb infrared radiation until they are the same temperature as their surroundings. Okay, so it will do it until then. It can't do it after then. Factors that affect infrared radiation transfer rate are if there is a large temperature difference, it will increase the rate. If there's a large surface area, that will also increase the rate. The colour or surface type, so for example, if it's black or matte, it will be the best absorber or emitter of infrared radiation, so that will increase the rate. If it's white or shiny though, they are the worst absorbers and emitters, so it will decrease the rate of transfer. Keywords to use actually in an exam question. You need to read the question, you need to decide what the object is actually designed to do. And then you can go on from that. Is it black? Is it white? Is it matte? Is it shiny? So then you need to use the words absorb or emit. Do not use both because then you will not get the marks. You need to show the examiner you know which specific one it is designed to do. If there's a large surface area or a small surface area, you need to talk about that also. And if there was a large temperature difference. This is an exam question that came up in January 2013. So it gives you a picture here. It says that the diagram shows a car radiator. The radiator is part of the engine's cooling system. Okay, so a big hint there. It then shows you a more in-depth picture that it has some cooling fins. And it says the coolant goes in at 112 degrees centigrade and it comes out at 97. So it's actually lost some temperature there. It then says liquid coolant heated by the car engine enters the radiator. As the coolant passes through the radiator transfers energy to the surroundings, okay? Telling you what it does there. And the temperature of the coolant then falls. It says, why is the radiator painted black? So if you want to attempt this yourself, pause it now. So the radiator is painted black, we should know, because it is the best emitter of infrared radiation. We're using the word emitter here because it's given out to the surroundings, okay? So that's just one mark. The second mark will always be for saying, so that increases the rate of infrared radiation transferred to the surroundings. The next part of that question, pause it again if you want. Different radiators have different numbers of cooling fins along the length of the radiator. The sketch graph shows how the number of cooling fins affect the rate of energy transfer from the radiator. So sketch graphs, you may be asked to draw these sometimes, do not require any numbers. They require you to label the axes, but it's more to show you a general trend. So it says then, the number of cooling fins affect the rate of energy transfer from the radiator. Explain how. 2 marks. So you see as the number of fins increase, so does the rate of energy transfer. So what you need to say here is that number of fins, or more fins, means a larger surface area, therefore there would be a higher rate of energy transfer. Here's marks here. So the first one, black or matte, is a good emitter of infrared radiation. Ignore any reference for it being a good absorber. Do not say the word attract. It does not attract. They really hate that. And then give maximum energy transfers to the surroundings. For the graph one, it was that the fins increase surface area, which then increase the rate of transfer. Okay, so it's really important these second marks are for saying about increasing transfer rate. And the flip side of that, in June 2014, they talked about an oven and biscuits being baked in an oven. Pause it if you wanted to attempt it. It says inside and outside surfaces of the oven are light coloured and shiny. Explain why. So for this, you would need to say that light coloured or shiny surfaces are poor absorbers or good reflectors of infrared radiation for inside the oven, and outside the oven also it's a poor emitter of infrared radiation, and the overall effect of that would be that there'd be more energy reaching the biscuits so that they would cook faster. So you see here it says inside surface is a good reflector or poor absorber, either's fine, and outside is a poor emitter. So you're using both this time, but you're using them for two different points, and that would increase the energy reaching the actual biscuits. Going on to conduction now. Now, to know whether it's a conduction question, you need to have a look if it's talking about which state. Is it talking about solids? It might not say straight out this is a solid. It might say it's plastic, it's glass, it's metal, it's wood. They are all solids, okay? There might be a picture of a solid object. It occurs in all solids, okay? Some people get confused and think it only happens in metals. It doesn't. It happens in non-metals, which are insulators, and it also happens in metals, which are conductors, but it happens in different ways, so you need to know both of those ways. Definition: it is the way that heat or thermal energy is transferred through a solid material. Explanation for it in non-metals. So this is a picture of a solid here. They're in tightly packed rows. You should know from kinetic theory that they all vibrate on a fixed position, but they cannot move anymore anywhere really. They have low kinetic energy and they have very high intermolecular forces. So particles in a solid are always vibrating, even though you can't see it, in a fixed position. When particles are heated, they gain more energy and so they then vibrate more, and this causes them to vibrate into the particle next to them, so it's sort of like a knock-on effect. Now, this is the one they like to ask mainly, and it is conduction in metals. The key thing about metals, as you should know from your chemistry, is that metals are actually attached together through metallic bonding, which means you get your positive ions and you have a sea of delocalized electrons within the metal, which sort of act like a glue keeping it all together. So because metals contain these free electrons, they're able to move through the metal quickly. So when you gain energy or heat, they travel through and they then collide with other metal ions, and then that causes the process to happen a lot quicker than, say, in a non-metal. Key words to use in your exam answer would be, do they mention it transferring through a solid? Is it an insulator or is it a conductor? So if it's an insulator, you need to mainly talk about the atoms vibrating on a fixed position, gaining energy and vibrating more, which transfers the energy through the solid. It's usually 2 marks max for one of those questions. If it is a conductor, so they're talking about a metal, you need to talk about the free electrons gaining energy and transferring that energy through. They travel faster and they collide. That is usually always a 4-mark question for those. So I've got one here from June 2012. If you want to pause it here and have a go, you can. Question 6, they usually, at the end of the paper, they tend to be the A star type questions. This one has been done so badly in the past because it's a very misleading diagram. So it says the diagram shows a metal pan being used to heat water, shows you a gas flame, it shows you a pan, shows you some water. Energy in the gas flame is transferred through the metal pan by conduction. They're telling you that. It then says explain the process of conduction through metals. They literally didn't even need any of that information there. They could have just asked you this question. But by putting this down, so many people I've seen in the past have talked about the gas flame and talked about the water being heated. It doesn't ask you about that. It asks you about the pan being heated, about the metal. So you need to talk about the metal gaining energy. You need to talk about the free electrons, like we just said before, travelling through, colliding, and then gaining energy. So if you see here, it says metal has free electrons. The energy of the free electrons increases, so they gain more energy. They then move faster. And then electrons move through the metal, transferring the energy to the other electrons, okay? You can say electrons collide with other electrons or ions, okay? It says accept atoms for particles for ions throughout, so you can say atoms, but the actual term is ions. Convection comes up just as much as conduction, really. Keywords to look for in an exam: are they talking about a liquid or a gas, okay? Is there a picture of an object that uses a liquid or a gas to transfer heat? It occurs in both liquids and gases. It doesn't occur in solids because they are in a fixed position, so cannot move around. Definition is it's the way that heat is transferred in liquids and gases. They transfer heat this way as their particles are free to move. The explanation here is that particles that are heated, they then gain more energy. So that means they move around more. By moving around more, it means that that particle occupies a greater volume of space, okay? It always has the same mass, because conservation of mass, but because it occupies more space, it means it becomes, this term here, less dense. And because it's less dense, it will then rise above any particles that are around it that are denser than it is. Okay, apology for the poor writing here. But if you can see, this is how I use to describe it. So if I had this circle here and that was my particle, and say it had a mass of 2 grams and it occupied a volume of 1 cubic centimetre, to work out its density, it would be the mass divided by the volume. So it would be 2 divided by 1, which would give us a density of 2 grams per cubic centimetre. Say that I then heated that particle, which still has a mass of 2 grams, but it then occupied a greater volume of 2 cubic centimetres. Then the density for this would be 2 divided by 2, which would then be 1 gram per cubic centimetres. So this particle here, although having the same mass, would now become less dense and would rise above this particle here. You may have heard the phrase convection current. And here's an example here. There's many examples. They can talk to it about a sea breeze. They love to talk about a boiler in a home heating system and gases in the air. So you can see that convection current moves through the room. By the time the air reaches here, it would have lost some of its energy and it's cooled down slightly. So it's talking about this position here. So you have a radiator here. So the radiator will heat these cooler particles, which will be more dense. They would then occupy greater space, become less dense, and therefore rise up. As it's rising up, it's going to lose some of its energy to the surroundings and become denser or cooler, which means that the particles will then fall down, they get heated again, and then you get this continuous convection current happening. Keywords to look for in an exam, to use an exam answer, would be talking about the particles being free to move, the air expanding, less dense, more dense, rise, fall, and convection current. Here is an exam question from June 2013. Pause the video here if you would like. It's talking about an electric immersion heater. Is used to heat a room, used to heat water in a domestic hot water tank. When the immersion heater is switched on, the water at the bottom of the tank gets hot. So it's got a little diagram here. Water goes in. Here's your heater. hot water gets heated, the water gets heated, gets hot, and goes out the top. Energy is transferred by the process of convection, so you won't get a mark for that, I've already told you, from the hot water tank at the bottom of the tank into the top. So for this question, you'd have to talk about the water at the bottom. So the water particles would gain more energy. This would cause them to expand or occupy greater space. This would then cause them to become less dense and then rise up to the top where the hot water goes out. 4 marks for this one. So you can see here, water particles, molecules gain energy, move faster. They then move apart, cause them to become less dense, and then it will cause it to rise to the top of the tank. Now, this was a question in June 2014, and it did confuse a few of my Year 11s who did it. It's a bit of a nasty question, really, because we're all taught heat rises, and so that's what we think about. However, if you look here, this design of the fridge freezer is that the freezer is at the top of the compartment and not at the bottom, so they're being a little bit sneaky here. It says that the air inside the fridge forms a convection current when the fridge door is closed, and explain why. 4 marks again. So this one, you'd have to talk about the air near the top, near the freezer compartment, would lose its energy, so become cool. Because it becomes then more dense, it would fall to the bottom of the fridge, where it would displace the warmer air that would be there, and that would cause the warmer air there to rise up, and then you'd form your convection current. So a bit of a sneaky question there. So it says air near the freezer compartment is cooled or loses energy. Cool air or dense particles are closest together. Air will fall, and then it will displace or move the air upwards, and that will rise again. Evaporation. Everyone goes, oh, I get evaporation, because you taught about it from when you were small children. However, it tends to be one of the more trickier questions, and it can be a question near the end of the paper, because they do require quite a bit of detail in it. So questions usually look for words, misty, steam, heated water, talking about drying anything like washing, sun, talking about puddle, situations, shower, puddle, clothes wash and drying, drinks. It occurs whenever you have water or liquid that is left anywhere. Definition is when particles within a liquid gain enough energy from their surroundings to allow them to leave the liquid as a gas. So if you see this diagram here, particles at a higher energy level are able to leave the surface and become gaseous. The ones at the bottom, the ones with less energy, wouldn't be able to do that. It has an overall cooling effect on a liquid when it evaporates, and this is why it's all about average energy of those particles that are left within a drink or a liquid. I always in my class use this example of a coffee cup, one with a lid and one without a lid. So if you have a look here, imagine we had these 6 particles. There is going to be more than that, it's just theoretical. And they all had this average energy, they all had an energy level differing. So we've got 4, 2, 5, 2, 9, 8. To find out the average energy of the particles within this coffee cup, I'd add it all up and divide by the number of particles. Done that, so it's 30 divided by 6, which would mean an average energy level of 5 for these particles within the one with the lid. Say if we then took the lid off, and if I said that any particle with an energy level of 8 or more had the ability, because it had enough energy, to leave the solution and become a gas. So here we have my 9 and my 8 have gone. They've now become a gas. Left within the liquid would be these 4 particles here of 4, 5, 2 and 2. So the average energy now of this becomes 3.25. So you can see by losing particles, especially the ones with the highest energy level, we get an overall cooling effect on a liquid. Ways to increase evaporation would be, number 1, increase airflow, so a fan, or if it's a particularly windy day. If you do that, then it has more chance for the particles at the top of the liquid to be able to leave, because they get energy from that kinetic energy that's being increased. Add thermal energy, they then have a higher energy level to increase the chance of them being able to become a gas. and increase the surface area of the liquid would mean that there's more particles on the top of the liquid, so again they have more chance to become a gas. Keywords to use in an example, in an answer, would be surface area, airflow, thermal energy, surroundings, and the average energy. So this was a question on a specimen paper, pause it now. It was the last question and people found it quite hard. So it uses a model here. It says that the diagram shows a tray of marbles being shaken from side to side. As this happens, some of the marbles jump out the tray. Explain how the tray of marbles is acting as a model for evaporation of a liquid. So it's 2 marks. So you have to say how this would be an example of evaporation. So the first mark would be saying that the marbles represent the particles within a liquid, and the ones jumping out the tray are the particles that are evaporating. It then says, before giving an injection, a nurse dabs some alcohol on the patient's arm. This makes the patient's skin feel cold. Now, a lot of people then put their biology head on and think, oh, alcohol kills bacteria. It's a physics paper. Keep your physics head on. So it then says, explain what happens to make this patient's skin feel cold. It isn't because the alcohol is cold at all, which some people think. It's because alcohol actually has a lower boiling point than water. It's actually 78 degrees. So it will actually evaporate at a lower energy point than, say, water would also. So when you have alcohol on your skin, it feels cold because those particles within the alcohol are actually taking your thermal energy and then evaporating from your skin. So they're taking your energy, which is why it then feels cold. This was a really, really horrible question for 5 marks on specimen paper. The graph is a little bit misleading, so I'd say don't tend to use it, although it says use a graph. You don't actually get marks for using it within the question. The main question here is, why does the liquid cool down when it evaporates? So you need to talk about here how, if you know anything about kinetic theory, particles within a liquid have a sort of medium intermolecular force between those particles. In evaporation, particles will gain enough energy from the surroundings to enable to break free of those intermolecular forces or bonds. By doing that, they then leave the solution. They're the ones that had the fastest particles. So therefore, the overall speed or energy level left within the liquid is lower than it was before. So this has an overall cooling effect on the liquid. So we go through the answers here. Marbles act as the molecules or particles was acceptable. The molecules leaving the liquid equals evaporation, or marbles leaving the tray equals evaporation. Evaporation requires energy, and so it's taken from the skin, and that's why it leaves your skin feeling cold. And then the horrible graph question was, there are attractive forces between molecules, these intermolecular forces. Only the fastest molecules have enough energy to break away from the other molecules. These molecules escape from the surface of the liquid or evaporate. Therefore, the average speed or energy remaining goes down. So the lower the average speed, the lower the temperature of the liquid. So the last method of heat transfer is condensation. Doesn't come up too much, usually paired with an evaporation question. Things you should look for are misty, cold surface, windows, mirrors. So it occurs when water vapour in the air comes in contact with cooler surfaces. So if it's cooler than that is itself, it will then, condensation will occur. Definition is when gaseous liquid particles come in contact with cool surface, they then lose their thermal energy to the surface. This means they then become liquid again. So you can see here, particles are further apart within a gas. They have high kinetic energy, low intermolecular forces. If energy is removed, these particles will then start to become closer together and become more liquid-like. Ways to increase condensation rate is you could decrease the airflow, so a bit opposite to evaporation, or you could also take away thermal energy. Keywords you need to use within an exam question. is you need to think about how is the condensation actually occurring. You need to then talk about, is it surface area, is it thermal energy, is it the surroundings, is it a cooler surface? So here's a question from June 2013, pause it if you like. It's a bit of a mix between evaporation and condensation. It says a picture shows a person taking a hot shower. It's taking the time to show that there's a mirror in the room. It then says when the person uses a shower, the mirror gets misty. Why? So you can't just talk about condensation here. You do have to talk a bit about evaporation. You'd have to say that the steam from the hot shower travels through the room, and then it will hit the mirror, and because the mirror is cooler than the water particles, it will then cause condensation. It then says that if a homeowner installed an electrically heated mirror into the bathroom or shower room, when a person has a shower, the heated mirror does not become misty but stays clear. Why does the mirror stay clear? So you have to say, you can't say the mirror is heated, you have to say that the mirror will be warmer. Therefore, when the gaseous particles come close to it, it will not condensate, so it will decrease the rate of condensation. So here you can see Na2 from water evaporates. Cooler air cannot hold as many water molecules. It will cause condensation on the mirror, and then the mirror is cooler. The next one, mirror surface is warm. See, it says here you can't say it's heated, which will then reduce the rate of condensation. Hope this helped.